Hi, my name's Maureen, and I run a Canadian nonprofit called Tech for Conservation, or T4C. In this video, I'll be presenting the African Carnivore Wildbook, an AI-driven software platform delivered by T4C to the conservation community at no cost. If you're looking for information about our citizen science platform, you can find a short video presentation about that system on our YouTube channel. Here's what I'll be covering. Obviously, what is Wildbook? What is the African Carnivore Wildbook? What do you do if you're not studying African carnivores? Well, no worries. Stay tuned. There's something here for you too. Of course, I'll walk you through the AI magic and some of the additional features and functionality of the system. So first, what is Wildbook? It is a fully open source AI platform for wildlife conservation and research. There are a number of different Wildbooks for different species, all developed and supported by WildMe, a nonprofit software and machine learning development company in Portland, Oregon. What is the African Carnivore Wildbook? It is a multi-species wildbook supporting the individual ID of these carnivores from photographs. Its purpose is to help conservationists understand who was seen where, when, and with whom across time, geography, generations, and species. Just this year, we added these adorable species to the platform. And as always, there will be more species and new algorithms developed and launched in the future. The African Carnivore Wildbook was created from a deep collaboration between Botswana Predator Conservation, who made the most valuable contribution, which was the data used to train the algorithms. Tech for Conservation funded the project, and WildMe built it. And here it is. This is the homepage for ACW. It can be found at africancarnivore.wildbook.org. ACW is being used to study carnivores in 15 African countries by almost 150 researchers and conservationists who have identified just under 8,000 individual carnivores from almost 25,000 sightings so far. So who uses ACW? Well, many large and small conservation organizations, educational institutions, private reserves, and many dedicated individuals. So what about other carnivore species out there? Well, for you, there's Whiskerbook, and newly launched in 2023, the Wild North Wildbook. So how does AI help with individual ID? Well, it helps accelerate the process. It can improve the accuracy of your IDs. It can make bad photos like mine easier to identify, and it's actually pretty fun. But what's the impact of that? It means that you can process much larger data sets faster than ever before. And larger data sets can now include citizen science data. In October of 2022, a short communication was published in Mammal Research regarding the use of ACW for reducing identification errors. Using ACW, researchers curated a 7-year camera trap dataset of cheetah and leopard individuals from north-central Namibia, previously identified by human observers. What they found was that there were 7% less cheetahs and 22% less leopard individuals in the dataset that they had previously counted manually. There are now a number of organizations that are also rerunning their historical datasets through ACW, just as this team did. So what does the AI do exactly? Well, it does a lot, but there are 3 key functions I want to highlight. The first is called detection, and that is, simply put, find the animal or animals in the picture and put a box or annotation around each of them. Detection is automated, thank goodness, but not always perfect. No AI is. Fortunately, the system has an easy way for users to add their own annotations when needed. That said, it can be pretty amazing. ACW's AI-driven detection goes beyond just boxes around bodies, though. It also labels viewpoints of the animals in the photo to be sure that right sides are only compared to other right sides, lefts to lefts, backs to backs. and whatever this wild dog is doing. Oh, there you go. It's a front right, everyone. Another automated feature of ACW is called background subtraction. As you can see from this example, using the original image on the left, the system masks out as much of the background in the image as possible, which you can see in the system-generated masked image in the center, and the composite version is on the right. This is super useful with camera trap images. So what about individual ID? Well, that's the next major AI-driven functionality in Wildbook called matching. How does it work? Well, first I select the animal in the image that I want to identify, called the target image. Next, I'll direct the system to look for matches to that leopard in the database. I do that by kicking off the ID algorithm, and the system will then find all possible match candidates and present them to me on the right. Then it's up to me, the owner of the data, to determine which of the match candidates are actually correct matches, helping to ensure a high level of data integrity. In this case, match candidates 1 and 2 were both correct. This is Tutu. So that's one photo, but what if you have a bunch of photos that you want to identify? Is there a limit to how many photos can be uploaded? Well, not so far. Although we do recommend choosing variety over quantity, burst images tend to clog up your match results. But this is a sample from the Cheetah Conservation Fund, the source of that recently published research I spoke about earlier. They have about 10,000 images in the system so far. And Botswana Predator Conservation, our co-founding organization, have just over 30,000 images in the system so far. So what exactly is the workflow? Well, it's simple. Here's my target image. I just click on the zebra box and select Start Match from the drop-down menu. I can also run matching from a whole batch of images all at once, rather than just one image at a time. That gives me match results for all of the images all at once, accessible from this single screen in ACW. So after I've kicked off matching, I wait while the system compares the patterns and textures in my target image or images to all other same side, same species in the database from the same region, until eventually I get this, a page of match results. You can see my target image here on the left, and the algorithm has offered me 12 possible match candidates, ranked from highest to lowest potential. Here I could change the default of 12 to 15 or 50 if I wanted to. But let's remind ourselves of what the goal is here. I want to know if we know who the leopard in the target annotation is. Because my target animal is unidentified, what I'm looking for is any match candidate that has an ID. In this case, the highest ranked match with an ID is match candidate number 1. This animal pictured on the right is ID'd as BPC's leopard, male leopard 32, nicknamed Rolo. It's interesting to note that these two photos were taken just over 3 years apart. So let's find out for sure if they're a match. To get more information from our ID algorithm, I can just click on the Inspect button, and I'll see a hotspotted or highlighted comparison between the target image and the match candidate, telling me what the algorithm sees as matching areas on the two leopards. It's cool, right? At this point, if I decide that my unknown leopard on the left is a match to Rolo on the right, then I click on the checkbox for match candidate number 1 and confirm that my target is BPC's male leopard 32, and instantly my target encounter record on the left is now ID'd as BPC LPM 32. And then I would do the same for any other further match candidates in the list that are also a match for Rolo. Here are a few other examples of matches from the system, correct matches. Everybody can understand bad camera trap images. It's a match between a puppy and an adult. Oh, and this one, it's ridiculous. So in this example, the detection algorithm didn't actually detect the tiny bit of tail on the right side of the image. Can you see that? But after an annotation was added manually by the owner of the data, the ID algorithm actually found a match, a correct match. And so now you know why I like to call it AI magic. But back to practicalities. Obviously, there's lots of additional functionality in ACW, but I'm just going to list a few here. Lots of features related to review of images, which is nice. Also, GPS data is automatically mapped. Multi-species maps are also possible. You can track relationships and social groups. Co-occurrence data is captured automatically. Your data is secured so that only those authorized by you have access to your data. It is securely stored on Azure. Your data is exportable. There are data integrity tools to help keep your data clean. ACW is a unified platform which drives data standardization no matter which user in your organization is working with the data. There are audit logs. And ACW is fully supported and maintained not by you, but by Tech for Conservation and WildMe. And finally, it's free. I'd like to thank all of these organizations and individuals for allowing me to showcase some of their animals and matches. And of course, WildMe for the AI magic. If you'd like an account, please contact us. Thanks.